Half a second, 500 milliseconds. That microscopic delay, spotted by a single engineer, was the only thing standing between the internet and global compromise. Had that delay gone unnoticed for a few more weeks, a patient attacker would have planted a permanent, silent entry point into global infrastructure, granting them administrative control over millions of cloud servers, banking grids, and government systems. The target was a piece of software called XZ Utils, and its underlying library, libLZMA. It is a command-line data compression tool. You rarely see it, but its efficiency and speed made it an industry standard, baked quietly into the base of nearly every major Linux operating system worldwide. This campaign failed because of one routine database test, succeeding where multi-billion-dollar enterprise firewalls and intelligence agencies didn't even know to look. Public assumption suggests that global digital infrastructure is maintained by armies of well-paid engineers in glass corporate towers. In reality, the modern internet relies on free, open-source software, frequently managed by solitary, unpaid volunteers working in their spare time. By the early 2020s, the weight of maintaining XZ Utils fell almost entirely on its original developer, a Finnish programmer named Lassi Collin. He did it as a labor of love, but the constant influx of hostile bug reports and demanding feature requests took a toll. He was dealing with long-term health struggles and deep mental exhaustion, all for zero financial compensation. In the realm of state-sponsored espionage, an exhausted, isolated maintainer is an ideal operational vulnerability. The attacker didn't start by writing malicious code. In late 2021, an account using the name Jia Tan appeared on the open-source horizon. For months, Jia Tan submitted minor, structurally sound patches to the XZ project. They fixed typos and addressed memory leaks, doing the unglamorous maintenance work everyone else avoided to project an image of a highly competent developer. Once Jia Tan established that constructive baseline, a coordinated network of sock puppet accounts, artificial personas created by the same adversary, was deployed to alter the project's psychological landscape. In mid-2022, personas like Dennis Enns and Jigar Kumar launched a synthetic pressure campaign against Collin on public lists. They complained about the lack of updates and accused the project of being dead. When Collin responded about his health struggles, the sock puppets used his burnout against him, arguing that XZ was too important to depend on one person. They explicitly pushed for Jia Tan to take over as co-maintainer. The psychological pressure worked. Overwhelmed by targeted hostility and real-world constraints, Lassi Collin welcomed the help. By late 2022, he granted Jia Tan commit access to the code repository and release management privileges. The adversary now controlled a vital node in the software supply chain. By securing trust before writing a single line of malicious code, they rendered the open-source community's strict review process irrelevant. With total administrative control, Jia Tan executed a complex architectural exploit. Take a look at this structural diagram. Downstream Linux distributions routinely modify upstream software for convenience. They patch OpenSSH, the secure gateway to a server, so it can talk to a system manager called systemd. To do that, the server links against a utility called libsystemd, which in turn links directly to libLZMA. This unintended dependency chain meant that compromising the compression library hijacked the entry point to the entire server. To hide the malicious payload from human auditors and automated scanners, Jia Tan turned to the project's test suite. They uploaded innocent-looking files labeled as corrupt binary data, supposedly meant to verify that the decompression engine could handle broken streams. In reality, these binary blobs were cryptographic containers hiding the encrypted backdoor. Then, the attacker used a split horizon strategy. When packaging software for distribution, developers use automated scripts to configure the build. Jia Tan injected hidden shell scripts into these tarball files. If you looked at the public GitHub repository, the code was perfectly clean. But when a Linux server downloaded the release package to compile the software, the hidden script extracted those test files and injected malicious object code into the final compilation. To trigger the payload without crashing the system, the exploit hijacked a legitimate optimization feature in the C library called ifunc. When an SSH login initiated, this dormant backdoor would wake up, It intercepted the server's authentication routines, actively scanning incoming connection requests to see if they carried the attacker's unique cryptographic master signature. If a normal user logged in, the backdoor instantly passed control back to the server, resulting in zero behavioral change. But if the attacker logged in, they gained full root privileges. Because the command execution happened entirely in memory before authentication completed, it was a zero-log exploit, completely invisible to security monitoring tools. A supply chain attack executed with this level of precision should have remained undetected for years. But in early 2024, Microsoft engineer Andres Freund was benchmarking database performance. During a routine test, he noticed his environment stuttered. Connecting to a server via SSH took exactly 500 milliseconds longer than expected. Even stranger, when he fed the login prompt a bad password, the system's processor briefly spiked to 100%. Determined to find the bottleneck, Freund ran advanced memory debugging tools. The processor cycles weren't being consumed by the security software. They were burning deep inside libLZMA, a compression library that should have been completely dormant during a login handshake. Freund pulled apart the release packages, revealing the hidden build scripts and proving how the test data was being weaponized. The forensic investigation into Jia Tan revealed heavy operational security footprints. The commits strictly followed a Monday to Friday 9 to 5 working schedule, accounting for international time zones, with notable absences during regional holidays. Furthermore, the backdoor's payload was guarded by an elite ED448 asymmetric public key, ensuring that even if rival intelligence agencies found the code, they couldn't weaponize it for themselves. The persona operated with the discipline of a corporate employee clocking into an intelligence office. It required 3 years of active, uncompensated manual labor before extracting any offensive value. That kind of strategic patience requires the budget and mandate of a nation-state. The discovery forced immediate technical remediation across the industry. Security architectures moved rapidly to decouple core network daemons, like OpenSSH, from unnecessary libraries. Build pipelines are shifting away from trusting pre-packaged archives, enforcing builds generated directly from cryptographically signed code commits. But the long-term shift is structural. Major tech institutions are recognizing that open source is the engine of the global economy, and it can no longer be treated as free labor. Initiatives are finally funneling capital to foundational maintainers, provisioning co-maintainers, funding professional code audits, and eliminating single points of failure. The XZ incident ignited a conflict of philosophies regarding the security models of open source versus proprietary software. The open source architecture gave the adversaries an unhindered blueprint, allowing Jia Tan to study the code and carefully craft an exploit over a multi-year period. But conversely, because the code and build files were open, an independent engineer had the legal and technical right to disassemble the library, profile its memory, and warn the community. While the openness of the software ecosystem creates an avenue for infiltration, that same transparency remains the only effective tool for collective defense.